In this lesson we're going to talk about nuclear energy, a controversial topic. Back after the Second World War, in the 1940s and 50s, there was huge optimism about nuclear power. Here is comments made by the Commission Chairman of Atomic Energy in the US in 1954. It's talking about some of the things we could get from nuclear power. Transmutation of the elements, unlimited power. It is not too much to expect that our children will enjoy in their homes electrical energy too cheap to meter, or know of great periodic regional famines in the world only as matters of history, will travel effortlessly over the seas and under them and through the air with a minimum of danger and at great speeds. So that was then. Energy too cheap to meter, a very famous quote. And scientifically there's good reason to think this. Here is a graph of energy density, how much energy you can get in a kilogram. You can see lithium-ion batteries is about 1 megajoule per kilogram. Fossil fuels plus oxygen is about 15. But then fission of uranium plutonium is 80 million megajoules per kilogram. Fusion, 639 million. The best possible as matter-antimatter combination, but that's not really practical. So the amount of energy you can get from a kilogram from nuclear fission, or particularly fusion, just blows anything else out of the water. And this is what led many people to think that this was the wave of the future. This is why the ANU has a huge nuclear physics department. It's because people were debating what is going to be the wave of the future back then, and they thought nuclear. However, 70 years later, nuclear energy supplies 4% of the world's energy needs. That's 10% of the world's electricity, but 4% of all energy. Pretty pathetic. Only one country, France, gets most of its electricity from nuclear power. France does very well by this. It gets 70% and it exports much power to other countries. Many countries are phasing out nuclear power. Germany is closing down its nuclear plants, and many other countries have bans on new plants like Japan, Taiwan, Italy, Switzerland, Belgium and Mexico. So what went wrong? Hint, it's not the physics. So, advantages of nuclear power. It's carbon-free energy that doesn't depend on weather or daylight. These enormous energy densities, so you could pack huge amounts of energy into a small area. And it's almost unlimited. Now, nuclear fission using uranium, the world's uranium reserves are about the same as the world's oil reserves in terms of energy, so it wouldn't last forever. But if you have either fusion or fast breeder reactors, then you've got essentially unlimited energy that won't run out. Now, elsewhere in this course, we've talked about replacing fossil fuels. But what can we do? We have to replace fossil fuels to stop global warming. But that's just taking something we could already do and doing it a different way, a different, less polluting way. But what could we do if we actually had a lot more energy? So if we had widespread nuclear power, in prehistoric times people used about 100 or a few hundred watts on average, which is the power of their own body plus a few animals. Currently it's 10,000 watts per person, mostly produced by fossil fuels. But if we had huge amounts of nuclear power, we could easily go to 100,000 watts per person, 1,000,000 watts per person. In that case, what could we do? Well, for example, we'd have desalination. We could make all the fresh water we like by taking salt water and getting rid of the salt. So droughts would be a thing of the past. We could grow plants indoors under artificial lights to provide all our food. We wouldn't need all the pollution caused by farming. No more famines. We'd have flying cars, no more traffic jams and space flight. So nuclear could be useful to replace our polluting fossil fuels, but it could go far beyond that in the future. But why not nuclear? Well, number one, front and centre are the huge public fears. People are afraid of nuclear accidents, nuclear war, radioactive pollution. Nuclear weapons proliferation. Nuclear weapons are spreading around the world, more and more countries have them. Quite apart from that, nuclear power is currently very expensive. It can't compete with solar, wind, or fossil fuels on a money basis. Maybe that will change, but at the moment it's definitely not a cheap form of power. And of course what you do with the radioactive waste is a big controversy. Now, the proponents of nuclear power would say, look, the public drastically overestimates the risk of nuclear power and underestimates the risks from the alternatives. So people will say a nuclear accident like Chernobyl spreads radioactive waste, kills thousands of people. Yes, but fossil fuel power plants pump out pollution which kills millions of people, far worse. First of all, it means there's public opposition. It also means that because people are so scared, there are ever more regulations about how you have to be so safe and have to have so many reviews before you can build everything, all of which blows the price out. So maybe that's why nuclear is so expensive. But it's irrational in some sense. Here are the death rates based on accidents and air pollution per terawatt hour of electricity. And what you can see is for every terawatt hour of electricity produced from brown coal, 32 people die. Some of them from air pollution, some of them from mining accidents. Black coal, it's 24 people. Oil, it's 18. And that's not counting wars. I mean, there's plenty of wars that have been fought over oil, in which case it would be much higher. Biomass, gas, hydropower. Yes, hydropower kills people. Again, it's construction accidents, plus a few dams that have burst and flooded away towns downstream. Whereas at the moment, wind, nuclear and solar are extremely safe. So that's the reality. Case against nuclear. Sure, nuclear is safe at the moment, but there's always the risk of something catastrophically going wrong, maybe polluting thousands of square kilometres so no one can ever live there for thousands of years. That's not a risk you get with other forms of power. Another argument against nuclear is that solar, wind and batteries are currently cheaper than nuclear, safer and more reliable. They're more reliable because they're more distributed. You put them all over the place rather than one big reactor in one place that could go wrong. What are you going to do with all the radioactive waste? And then there's a trust issue. I mean, governments have a pretty bad track record of lying about all sorts of risks, including nuclear risks. Why would anyone believe them now if they say, oh, this is perfectly safe, we've learnt our lesson? There are plenty of times where governments have promised that things are safe in the past and been lying. And perhaps public opinion is now so immovably fixed against all things nuclear that nothing we can do is going to change it.